Let's look at the procedure for solving definite integrals when we have a u-substitution. For example, I want to integrate -2 to 3 the square root of 2x minus 3 dx. So I'll first rewrite that as the integral from 2 to 3 of 2x minus 3 to the 1/2 power so that we can integrate it. But since that's more than just plain x, we know this is a u-substitution problem. So my u is 2x minus 3. Calculate my du by taking the derivative of the u expression. So the derivative of 2x is 2. The derivative of the minus 3 is a 0 dx. So now to get dx by itself, I got to divide by 2. And we can substitute in. So I have the integral of u to the 1/2 dx is replaced by du over 2. Now here's the problem. I have a definite integral is equal to an indefinite integral, and that's just not going to work. It's got to be a definite integral is equal to a definite integral. But I can't put the same bounds down. I can't put 2 and 3 down because those are bounds on x, not on u. So to get the new bounds on u, I plug in the bounds to the u equals equation. So my new lower bound is going to be 2 times 2 minus 3, and the upper bound would be 2 times 3 minus 3, where I'm just plugging in the upper and lower bounds that were on x into the u equals equation. Okay, let's go ahead and simplify that. So we would get there, the integral of, that would be 6 minus 3 is 3, u to the 1/2 du. My 1/2 comes out front. My lower bound is 4 minus 3, which is 1. So that's 1/2 times my antiderivative of u to the 1/2 is going to be 2/3 u to the 3/2 from 1 to 3. Notice that because I changed my bounds, I do not need to resubstitute. So I go ahead and simplify the 1/2 times 2/3. Now we're just going to plug in the upper bound, 3 to the 3/2 power, minus the lower bound, 1 to the 3/2 power. When I change my bounds, I do not resubstitute. So there's my solution. All right, let's look at another example. Let's say that we want to integrate from -pi to pi over 2 cosine of x times cosine of the sine of x dx. So again, I need to choose a u value here for my u substitution, and one thing that I might notice is that I have a composition right here, cosine of the sine of x. So since there's more than just an x inside the cosine, that's a good pick for my u. So u would be the sine of x. Calculate the du, cosine of x dx. Oh, look, that's exactly what we have sitting right there. So I can go ahead and make my u substitution. So it would be the integral of, this part here is the cosine of u, and then these two together make the du. Now, again, I have the same problem. I don't want to say a definite integral equals an indefinite integral, so I'm going to change my bounds over. So we plug the -pi in here. This is going to be sine of -pi. Sine of -pi is a 0. And then plug the pi over 2 back into this u equals expression. Sine of pi over 2 is a 1. So now we can find the antiderivative of the cosine of u. That's the sine of u. Evaluated from 0 to 1, that's going to be the sine of 1 minus the sine of 0, the upper bound minus the lower bound. And now we go ahead and evaluate that and simplify. Sine of 1 is, don't think too hard, that's not on the unit circle. Remember, 1 is a real number, right? All of those pi angles on the unit circles are representing real numbers. Pi is approximately 3.14 and so on. So sine of 1 is sine of 1. I can't simplify that any. So it's just sine of 1. But sine of 0 is 0. And we have our solution.